See, actually, today's class is input-output model. This model given by Wesley Leontiff. For that, he used a two-sector model. In that, only one factor of production called labor is utilized. So, why he has given? In order to understand the relationship between the input and output, because some sector will have the output, some of part of their output will be utilized by their own. The remaining will be sent to the other industry. So he made one simple model by using the hypothetical value with the 3 by 3 matrix. That is, yes, Pritika, have any doubt you can ask me. Pritika, you raise your hand. Let me know. What's your doubt?
No, sir, no doubt. Without
okay, shall I continue?
Yes, sir.
Based on this particular hypothetical values, the total output of agriculture is 240, out of which 30 is utilized by their own, and the remaining output 170 utilized by manufacturing industry, and other is 40 for the household and government sector. Similarly, for manufacturing sector, total output is 150, out of which 25 utilized by their own, and 45 for agriculture, and final consumption by government and individual is 80. Excuse me, madam. Now, actually, based on this particular hypothetical value only, the input-output model is framed by Wesley Leontiff by considering agriculture and manufacturing as a two sectors, and they are using a particular factor of production labor force. The total labor force is 70, out of which 20 for the agriculture and 50 for the manufacturing. Based on this particular value, I'm just interpreting that. You can see the first column, the agriculture is total output is 240. But how much it is input is they are using 30 for agriculture and 45 for manufacturing, and 20 units of labor is employed, totally 95. But output is 240. So there will be a profit of 155 units. This is in case of agriculture. Now you can see the values of manufacturing. The total output of manufacturing is 150. But how much it is using, you can see from agriculture itself, they are using nearly 170 units. Have you seen it? The second column and first row. And 25 they are using their own, and 50 units of labor force is used. Totally, if you add 170 plus 25 is 195, 195 plus 50, 245. Okay, what is the total output? 150. So what is the loss from the manufacturing industry is 95. So how we can compensate this? Because there is 150 units profit in the agriculture sector, and nearly 150 units is lost from the industry. So in order to understand which sector is performing well, so they made one particular matrix form. Instead of saying agriculture sector and industrial sector, we are taking n number of industries now, and in the column and the row they are making industry 1, industry 2, industry up to n industry. Similarly, in the row up to n industries. One side, what is the total purchase made by respective industry? Another side, what is the sale made by. So, for example, in that particular matrix, X11 means the first industry using the input as the first industry. Then what is X12? The first industry is the output, the second industry is input. Similarly, up to X1 is the first industry output, the nth industry input. Likewise, for the second industry, we can write X21 means the second industry's output for the first industry. X22 means the second industry output for the second industry input itself. Similarly, it will increase. What is the third column? It will be X23, second industry output for the third industry input. Likewise, it will continue up to n industry. Then what is the last one? X2n, that is second industry's output for the nth industry input. So we frame that particular matrix. We can aggregate by using the simple logarithmic thing. Summation of x1 equal to is nothing but what is the first industries to the jth input. We may say x1j. Summation of x1j is nothing but the input output value of that particular. It may say it is a total output produced by the first industry. Likewise, for the second industry, what will be the x2? It will be summation of x2j. Up to nth industry, it is summation of x in j. This is in case of sales. Coming to this purchase side, we may make x1 is a total output, x2 is for the second industry, x3 for the third industry, up to xn. So in order to maintain that relation, it will be linear relation. We are saying for before making that particular linear relation, he made three assumptions. Keep it in mind. Without these three assumptions, the model will not hold good, because he is assuming that each industry producing only one product, that too homogeneous. This is the first assumption. Then the second assumption is they are using the fixed input ratio for their production and its output. So it is a constant elasticity. That is, we may say constant return to score. That is the third assumption. So based on these three assumptions only, he framed the particular model. How he made it? One side is input, other side is output. Input 1 to n industry, output 1 to n industry. Instead of saying x1, x12, x13, he just made a11, a21, a31, up to an1. Why? This is the link between their input and output. For example, the first input output relation a1n means the first input to the first output. A21 is second first industry output for the second industry. Likewise, an1. So if you see that particular principal diagonal a11, a22, a33, a44, so ann up to this principal diagonal is nothing but their output. They are using their input. So how we have to make that particular equation? It's very simple. This matrix will be expressed in a linear form. Summation of I equal to n to 1 to n will be aij, which is less than 1. Why it is less than 1? Suppose 100 units produced by particular industry means that 100 units is equal to 1. More than 100, nobody can use. So this 100 is divided into 10 industry, 10, 10, 10 means. So what is that particular thing? Summation of 1 to n means it's nothing but 0 to 100 or 1 to 10 industries will be represented by aij. Here I is the input, j is the output, which must be less than 1. It is in a proportion only. So where j is 1 to n. So this particular equation can be easily expressed in a linear form by taking the principal diagonal as 1 minus a11. In the second industry, 1 minus a22. For the third industry, 1 minus a33. So that principal diagonal will be taken as an identity matrix, and convert that particular identity matrix. You can see the rest of the input output division will be less than 1. That is why there is a negative sign. So how the matrix will be? 1 minus a11 x1. Then second element is minus a12. Third element is minus a13 up to minus a1n. This is the first row. For second row, it is nothing but minus a21. But the second element is second industry, second output, second input. So it should be 1 minus a22. Likewise, for the third industry, the third element will be 1 minus a33. Likewise, up to nth industry, it should be 1 minus ann. With this particular n by n matrix, when you multiply with the output of each industry, x1, x2, x3 up to xn, we can get the d1, d2, d3. D1, d2, d3 is nothing but the input output relation. When you subtract with the identity matrix with the actual input output matrix, we can get the actual input output relation, which can be expressed as I minus a. Here I is nothing but identical matrix. With the identical matrix, when you take the actual matrix input output matrix, multiply with the x, we can get the actual determinant. In case if it is not possible to do directly, we have to take the ultimate value is how much output that I need. So X is the independent value. The rest of the I, A and D are dependent value. So keep all the dependent value on one side, the other value that is independent value in the other side. So X equal to I minus A. Here I is a identical matrix. A is the actual input output matrix. They take the inverse because from left side is come to right side, so inverse. I minus A inverse into D. So in this particular equation, if you construct like production possibility frontier, we can get the consumption possible frontier, because this can be represented which industry is supplying the input to the which industry. We can say one industry's output will be the input for the next industry. There will be n industry. So this particular link will give what will be the input output link, and it is easy for us to take a decision. This particular model was developed by Wesley Leontiff, and it has been further developed by Hawkins-Simon model. This Hawkins-Simon only, using the Wesley Leontiff input-output model, he constructed the consumption possibility frontier. This particular question they may ask the case study. So what I want to suggest you, some mathematical interpretation is there, because converting that particular input output into the equation, most of the people find difficult in this. Those who are weak in maths, don't feel bad, just multiply those two equations, because for the first equation you have to put 1 minus a11. For the second equation you have to put the second element 1 minus a22. For the third equation 1 minus 33. So the third element, so the principal diagonal should have 1 minus. The rest of the thing give the negative. Why it is? It's nothing but we are taking the equation a particular thing, summation, that is integration of 1 to n aij will be less than 1. Because of this particular equation, we are having this particular linear form, summation of a1n from I equal to 1 to n with the multiplication of x1 plus d1. This particular thing is nothing but, this particular d is nothing but the demand. For example, an industry is there. The first industry will totally 100 units they are producing. So he is giving 10 units to each, means A11 represents 10 units of first industry's output with the first industry input. Then what is A12? The first industry output for the second industry input. Likewise, A12, A13, A14 up to A1n. N is a 10. So 10 units of the first industry output used by the nth industry. So that equation is represented as a linear equation, which is equal to D1. D1 is a demand for the output of the first industry. Likewise, D2, D3, D4 up to Dn is D2 represents the demand for the second industry. D3 represents demand for the third industry up to nth industry. So you just make that particular principal diagonal, keep it in mind, 1 minus a11, 1 minus a22, 1 minus a33 up to 1 minus ann. If you put that particular equation correctly, then it's easy to form this particular matrix. In a matrix notion, we can take only the values, multiply with the x, which is equal to the demand. So that equation can be represented by x equal to identical matrix I minus a power inverse into d. That is the linear equation. Definitely, this is a scientific one. We can apply even today. This holds good. With this, I am completing the class. If you have any doubt, you can ask me. But those who want to have a strong in this, you have to write the assignment in this. What I given in the PowerPoint, just enter in the notebook, go through once. Definitely, you may have some doubt. You can ask me in the next class. I will clarify. But once you understand, this is the easiest concept. Unless and otherwise you understand this concept, it is not possible. But my request is, don't mug up. Understand the concept. If you have any doubt, you can ask me. This is a confirmed section C question. You can expect the case study in this with the given values. They may give some values. If you have any doubt, you can ask me.